Hello everyone, Siddharth this side, and today we will be solving another question on lead code, which is minimum number of moves to make string a palindrome. So what we have to do in this problem, we have given a string and we have to count the number of moves, minimum number of moves by which we can make that given string to a palindrome. So if you guys don't have idea what is a palindrome, so let's first discuss what exactly a palindrome is, and then we will be discussing our brute force method, and after that we will be discussing a efficient approach. So let's move on to the whiteboard. So what is a palindrome? Let's first discuss that. So palindrome is something which is exactly similar from left side if we compare from the right side. So let's take an string as an example. So st e. So this string is a palindrome. If we compare it from the left and right, they will be exactly similar. So t is equals to t and this e is in the middle. So if we read it from the left, from the right, it should be same as if we read it from the left. So now let's move on to the brute force method. So in the brute force method, what we will be doing, first we will be finding the total number of permutation of a given string. So permutation, all permutation of given string. So after finding all permutation of a given string, what we have to do, now we will check each permutation, check each permutation. After checking each permutation, we will find those permutation only which is palindrome. So we will take these palindromes string. Now we will check our original string and we will keep track of number of moves, and we will see how we can convert our given string to this palindrome. So suppose we have this ste, let's take t here and e here, and ste, e, se. So s, okay, this is looking good. So now what we will do, we will find all the permutation of this given string, and one of the permutation of given string will going to be our palindrome. So we will take that, and one or more than one permutation also can be palindrome, and in those palindrome we have to find that palindrome which will be achievable in minimum number of moves. So what's our target here? What's our target permutation? That will be going to be st, and e. So this is a required permutation, and in this string only this is possible. Like this is also possible, ts, e, and s and t. This is also possible, but we have to keep tracks of number of moves from our original string. But this solution, guys, will take omega big O of n factorial, because we have to find the all the permutation. So if you don't know, so if you want to find the permutation, like in 11th class we have studied this, which is, suppose we have to find the permutation of these four numbers, 4, 5. So in the first place, the total possible digits can come, total possible number can come, will going to be 4. Now we have used one number, and suppose we have used 4. Now the required the left number will going to be 1 to 5. Now these three number can come to this place, and now 2 only and 1 only. So the permutation will going to be, number of permutation will going to be 4 into 3 into 2 into 1. So 4 3 is 12 to the 24, which is 4 factorial. we will write this as a shortcut, which is just decrement the number and multiply it up to 1. So now let's discuss the brute efficient approach, because this approach is not feasible. So in the efficient approach, what we will be doing, guys, so as a palindrome, what is suggest that it is similar from right and left. So one idea that can come to our mind is that we will keep track of our first character, which is from the start one. Let's take this STETS. So we will keep track of this character and this character. Now what we have to do, we have to find the index of this number, which is S. So this is the correct answer, but this is not going to be the case. S can be present here. Let's take E here and S here. So now the index of S will going to be 0, 1, 2. So 2 is the index of 1. We will find this index. Now we will add this index to our moves. We will keep track moves as a variable, and we will increment it by index value. So we will increment our move to 2. Now what we will do, we will delete this character from our string, but we can't delete it from the string. For that we have to convert this string to string builder. So after converting it into a string builder, we can easily delete or remove character. So after deleting this, our string become ET, and after deleting this S and this S, because we have handled this S, like what we are exactly doing, we will be counting its index value from here, which is exactly the number of moves that it will take to move here. And now S will come here and S will come here. We will not swiping, we are just counting the moves. So now we can delete these two characters, because now we don't have to consider these, because we already had handled these cases, already handled these two characters. So now our string become ET and T. Now we will compare these two characters. So after finding the index of our last character, which is T, which is 1, we will increment our move by 1. Now move will become 3, and we will, what we want to do, we have to move this T to here, then our string become TET. Now the only character will left is E. So this is our edge case, guys. When there is an odd number of character in a string and that is a palindrome, then there will be one character left, like S, T, E, T and S. This character, if it is present in the last, like if we encounter this character in the last, we have to move it into the center, because there is no character we will find in the remaining string, and we have to move it to the center. So we will increment our moves by index divided by 2. So STETS. So we will increment our moves by index divided by 2, because we want to move this E to here. So now let's now you have guys understood what is the idea behind this question. So let's solve this question. Okay, so first we will initialize the number of moves. So int moves is equals to 0. Now what we will do, we will initialize a string builder and convert our string to that, so that we can easily remove or delete elements. So string builder SB is equals to new string builder SB. Now what we have to do, we will start traversing into our array, and we will traverse until our length of our string will become less than 3. So while SB dot length is greater than 2, what we will do, we will find a first character. So char 1 will equals to SB dot char at here at index, which will going to be 0th index, because we want to find a first character, and after that we will find our character 2, which is sb dot char at index sb dot length -1. Now after finding these two characters, we have to find the index of second character. So int index, this will going to be sb dot index. So this is a built-in function to find the index of a given string, but currently a character 2 is in char data type, so we have to convert it into the string data type. For that we will be using another built-in function. So string dot value of char 2, so this will convert this character to a string. Now what we have to do, we have to check some condition. First we will check our edge case. If our length of a string is odd and there is only one character and it is in the last, so we have to move it to the center, and we will update our moves. So that will going to be if our character 1 does not equals to character 2, and another condition will going to be if this index value is equals to uh, sb dot length -1, which is it is occurring in the last, and character 1 is does not equals to character 2. So now what we have to do, we have to increment our moves to index divided by 2, because we have to move it into the center. So that will so we have to increment our moves by half the length of our string. So now in the else part, what we have to do, we have to increment our moves by the value of index. So index. Now what we have to do, we have to delete that character that we have find already, and we have handled last two character, first and last character. So first we will delete that character, which is character 2. So sb dot delete char at index. So this will delete this character. Now what we have to do, we will have to remove our last character also. So we will sv dot, this is also built-in function. So why we are using it, because this is efficient as compared to deleting the character, because deleting a character will take traversing up to the end. So we will be using this one. So sb dot set length up to sb dot length -1. So by this we will be removing our last element of our string builder, and in the last we will be returning our number of moves. So let's check everything is fine. sb dot length -1, string dot value of char 2. Okay, now let's try to run this code. Okay, this should be bracket here. Okay, now let's try to run. This should be s, not sb. Okay, so now let's try to submit this. Okay, so we have successfully solved this problem. So thank you, see you in the next video. Bye.